I'm going to guess that most of you never really posed yourselves the question of why is it that when I look around me, the world is mostly green? Well, in a seminal paper in 1960, Hairston, Smith, and Slobodkin tried to propose some ideas as to why this was actually the case. And in this essay that they wrote, they basically gave some examples of situations where the world actually wasn't green, where there were instances where there was defoliation and overconsumption, you might say, of the plant material that was in a particular community. And they categorized them into the following examples. They said, often when we see this kind of defoliation happening, it's in the case of species being introduced into an area where they're not native to. For example, the gypsy moth here. This was a species that was introduced into North America in the late 1800s to try to start a domestic silk industry. There's so many things wrong with this, I can't even start. But the short of it is that the moths got out, and slowly they've been marching across the U.S. from Massachusetts. The invasion front went through Wisconsin in the early 2000s, and they're still kind of moving out. And where they go through, you actually see these areas of complete defoliation where the trees are stripped clean of every leaf that they have, and it's the caterpillars that are doing most of this. The females are actually wingless, and that's why this invasion front has taken a long time. And as we learned from our example in the very beginning of the class, this has to do with, that part of the reason for this has to do with the fact that there are no native predators that can actually utilize these herbivores very well. And so the populations can get quite large. Speaking of predators, other examples, and there's many well-documented examples of where predators have actually been removed from a particular ecosystem, either through overhunting, as was seen here in the Yellowstone area, where wolves were extirpated, and in the consequence of that is that large ungulate browsers like these elk here were able to but they were able to defoliate the riparian vegetation, and in fact limiting recruitment of things like poplars along streams and so on. So the vegetation in these environments where wolves were removed is completely different than one and where wolves are there and able to keep elk under suppression. There's many other really well documented examples of this in marine systems and other places. In agricultural systems, you have examples that look something like this, something that's referred to as pesticide resurgence. This is an example, for example, with the brown rice plant hopper, Nila parvata lugens. This is one of the most important key pests of rice in Southeast Asia, rice being one of the most important staple crops for calories in the world, actually. As these populations start to grow, growers, particularly in the 60s and 70s, and even today to some extent, resorted to broad-spectrum insecticides to control these insects. What happens is these kill off not just the herbivores, but they also kill off the predators, like these generalist spiders here. These spiders have longer generation times than the herbivores, which means that the populations of these guys can rebound quite rapidly, causing damage to the plants. Here you can see this classic, what's referred to as hopper burn. This is actually a plant reaction to the salivary secretions and to the feeding of these homopterans on the plants, which completely shuts down the photosynthetic system and can cause significant damage. And this can happen because there basically are no predators around. And the flip side of this is instances, like we learned early on in class, where predators have been reintroduced into a particular system, as is the case of classical biological control. And when this predator-prey interaction is reestablished, you get the suppression of the herbivore and the lack of consumption of plants, and therefore a green world. So under the analysis of Hairston, Smith, and Slobodkin, what they proposed was that the reason why we have lots of plants in the world has to do with the fact that herbivores, those things that consume, have these negative effects on plants, are largely kept in check by the third trophic level. In this very simple kind of food chain system, this is the first trophic level, primary producers. This is the second trophic level, herbivores. And this is the third trophic level, the predators, parasites, parasitoids of these herbivores. So this second trophic level is kept in check by the third trophic level, thereby releasing plants from extensive herbivory. This is exactly the situation of what we try to create in biological control, manipulating in some way the natural enemies so that we gain some benefit from the plants. And they argued that this logic is pretty hard to refute, that top-down control is actually what maintains the world green. Well, the remainder of this particular lesson is really trying to explore some alternatives to this particular top-down hypothesis. Turns out, as you can imagine, plants are not sitting ducks, and plant-herbivore interactions have been evolving for millennia. So plants have evolved a variety of ways in which they protect themselves from herbivores and from the loss of this very hard-earned tissue that they've put together. And the situation looks something like this, where plants have a variety of traits. You can call them defenses, but things that can act directly on the herbivore that either constitute physical properties of the plants that reduce herbivory, or chemical defenses. In fact, this is an amazing area, and we're going to learn much more about it. Plants are incredible chemists, and they have a whole suite of compounds that they create that have negative effects on herbivores. These sometimes are referred to as the direct defenses, those things that act directly on the herbivores. But plants also have figured out ways, you can call it that have traits that interact or have effects on the third trophic levels so that their activity is enhanced and herbivores are maintained at lower abundances. You could think of these as indirect offenses, things that facilitate the impact, traits of the plants that facilitate the impact of natural enemies on their herbivorous prey. And these are traits that can be selected upon that confer fitness advantages to the plants. And so we're going to explore all of these in the next couple of lessons.